Suppose once again that we have 2 points, A and B, and let's look at the line segment that joins those 2 points. If M is the midpoint of that line segment, then the perpendicular bisector of A and B is the straight line which passes through M and is perpendicular to the line segment AB. Our mission is to work out how to calculate the equation of the perpendicular bisector of 2 points. Well, what we will need to know to do this is both the gradient of this perpendicular bisector and any point that it passes through. But of course the point it passes through is M, and we know how to find the midpoint of A and B, and the gradient of the perpendicular bisector can be found from the gradient of the line segment joining A and B. We therefore have a general method. Firstly, find the midpoint of A and B, let's call that M. Then find the gradient of the line joining A and B, let's call that M1. Find the perpendicular gradient M2. And finally, find the equation of the line passing through the point M with gradient M2. In this example, we have points A and B with coordinates 1, -4 and -5, 6. We have to find the equation of the perpendicular bisector of the line segment AB. So, going through our method, firstly, let's find the midpoint M of the points A and B. 1 subtract 5 divided by 2, -4 plus 6 divided by 2. We just have to average the coordinates. That gives us -2, 1. Next, find the gradient of the line joining A and B. So little m1, gradient of line 1 will be -4 subtract 6 divided by 1 subtract -5. We've got -10 divided by 6, which is the same as -5/3. Now we have to find the perpendicular gradient. Let's call that M2, and we know that we have to do this by doing -1 divided by M1. In other words, -1 divided by -5/3, which is the same as -1 multiplied by -3/5, which therefore is 3/5. Now we have a point and a gradient, so finally the equation of the perpendicular bisector using y minus y1 is mx minus x1. That equation is y subtract 1 is 3/5 into x subtract -2. Have to tidy that up a little bit into y minus 1 is 3/5 into x plus 2. But since in this case we've not been asked to give our final answer in any particular form, we could stop there. You may have to tidy it up into a y equals mx plus c or ax plus by plus c equals 0 form, but this will do in this case. In this question we have to find a point of intersection of the perpendicular bisector of the line segment joining a couple of points that we're given and another straight line that we're given the equation of. So we'll have to start off by doing exactly the same thing. We're going to have to find the equation of the perpendicular bisector of those 2 points. The midpoint of the line segment AB is 3 plus 11 over 2, 0 subtract 6 over 2, so our midpoint is 7, -3. The gradient of the line segment joining A and B is -6 subtract 0 divided by 11 subtract 3, so -6 over 8, which we could simplify to -3/4. That means that the perpendicular gradient is -1 over -3/4, which is 4/3. So our perpendicular bisector is y subtract -3 is equal to 4 over 3 into x subtract 7. Now, we need to tidy this up a bit because we're going to have to compare it to another line which has been given to us in the ax plus by plus c equals 0 form. So let's tidy our equation up so it's in the same form. Y plus 3 is equal to 4 over 3 x minus 7. Let's multiply through by 3, giving us 3y plus 9, and also expand the brackets on this side, is 4x subtract 28. Getting everything on one side, we have that 4x subtract 3y subtract 37 is 0. Let's call that equation 1. It's the equation of our perpendicular bisector. But we've also been given the equation of the other line we're interested in, which is 2x plus 3y plus 1 is 0. Let's call that equation 2. So we have to solve these simultaneously to find the point of intersection. Why don't we add these equations together? In other words, if we've got equation 1 plus equation 2, that gives us 4x and 2x, gives us 6x. Negative 3y and 3y gives us nothing. Negative 37 and 1 gives us negative 36. So that means that 6x is 36, which means that x itself is 6. That's only the x-coordinate of the point of intersection. We'll need to find the y-coordinate as well. We could use either of the original straight line equations, but it's easier to use equation 2. So in that case it says that 2x, and we know that x is 6, so 2 times 6 plus 3y plus 1 is 0. That means that 3y is negative 13. That means that y is negative 13 over 3. Not the nicest coordinate, but we therefore know that the answer to the question is the point of intersection is 6, negative 13 over 3.